Okay, welcome everyone. So today we are going to begin the third unit, and this is functions and composition. I know many of you have studied this one. It's going to be a review for many of you, but new concept for some of you. So let's explore. First, we're going to look at the definition, and I also encourage you to write the definition so that you know the meaning of function here. So when I say function, it is a relation in which each possible input values, let me try to highlight some of the things here, in which each possible input values lead to exactly one output value. So if I look at these three diagrams down here, everybody look here, see, for this, the values on the first group, they are called the input values, and values on the second group, they are called output values. So you can see that this P, the input P has only one output M. Input Q has only one input N. R has only one output. Q has only one output N. Similarly, R has only one output N. Same thing on the second, you can see P has only one output, that's X. Q has only one output, that's a Y. And R has only one output, that's a Z. That means these two, the first diagram that is here, the first mapping diagram, that represents a function. The first mapping diagram represents a function. Similarly, the second one also represents a function. But if you look at the third one now, see, P has only one output, that's a X. But if you look at Q, Q has two outputs. The output is Y and Z. If there are more than one output for a single input value, that is not a function. So we say that the third mapping diagram does not represent the function. So that is the definition. So we can say that a function is a relation in which each possible input value leads to exactly one output value. And we say that the input is the function, the output is the function of input. So whatever we get here, it is the function of these values. And remember, the input values are sometimes referred to as the domain of the function. Okay, the input values make up the domain. Input value represents the domain of the function. So all input values, they are called the domain of the function. So for example, in this first mapping diagram, the domain will be P, Q, and R, that is the domain. And the range will be M, N, that is the range. So for the first mapping diagram, if I want to write it down, see, for the first mapping diagram, I can write just below that. Domain for the first one is P, Q, R. And the range, as it is said in the definition, the output values make up the range. Okay, the output values make up the range. Let me also underline that first. So if I want to write the range, the output values here are M and N. M and N. They are the range. Similarly, for the second one, if you look at the second function here, because the second mapping diagram also represents function. So the domain will be the set of input values. Here the input values are P, Q, and R. P, Q, R. That is the domain. And the range will be, you can see the output values are X, Y, and Z. So these are the range. So we write X, Y, Z. Okay, first two are functions. And for those two functions, we have also identified the domain and the range. Now, mathematically, If we want to represent the domain and range, we represent a little differently. We write it like this. The notation y equal to f of x. This is kind of very famous notation for the function. Okay, the notation y equal to f of x here is the way we represent the function. The notation y equal to f of x defines the function f. Okay, define the function named f. So if we see y equal to f of x, we are talking about the function f. And when we read this as y is the function of x. Okay, y is the function of x is written as y equal to f of x. And remember, here the set of input values x, the first set, just like here in the diagram, the set of input values x is the domain. Input values x is the domain. And the set of output values is the range of the function. So when we're talking about the function, we should know what are the domains, what are the range, and also we should know whether the given mapping or given relation is a function or not. For the given relation to be function, look at this key sentence that we have seen up here. The input value leads to exactly one output value. For every input value, there should be only one output value, then only it's a function. Otherwise, it is not a function. So based on this definition and this fundamental concept, we are going to look at a couple of examples today. Before we move on to example, if you have any question, you can ask me now. You can unmute and ask, or you can send question through chat. And also, if you have not finished writing this, make sure you finish it. So I'm going to pause here for a little bit. Okay, I hope you are done copying it. So let's move on to examples. So here is the first example. You can copy the question. So in this example, we are asked to determine whether the following relation represents function. So we know that if the relation represents function, then for each input value, you will have only one output value. So what we can do is for these two questions here, we can create the mapping diagram and then identify whether it's a relation or a function. So for the first one, A, what we'll do is we'll draw the mapping diagram. Okay, we'll draw the mapping diagram. So this group is for the input values and this group is for the output values. You can just draw two circles or two ovals or just two groups, whatever you want. Now, look at the screen. Here we have A comma B. That means if the input value is A, the output value is B. That is the meaning. A is mapped to B. So that means for this A, there is the image B or output B. Now C is mapped to D. C comma D means C is mapped to D like that. And then A is mapped with C again. So if you look here, the next one we have is A is mapped to C. See, over here we have A mapped to B already. Now next we have is A mapped to C. A is also mapped to the other value C. So you can clearly see here, this one, C has only one output. C is mapped to D. That means C has only one output. But if you look at A, the input value A has two output. That is, it is mapped to B and also it is mapped to C. If it is mapped to more than one, it is not a function. That means the first one is not a function. Not a function. Okay, the first one does not represent a function. We have to determine whether the relation determine a function or not. So this is not a function. This is just a relation. It is not a function. Because if you look at the definition one more time, the input value leads to exactly one output value. There should be only one output value. But here, this A has two output values, B and C. That is the main reason why this is not a function. Okay, let's move on to the second one, B. So we're going to create the mapping diagram again. So let's create the mapping diagram for B. You can draw two groups like this. You can draw a perfect circle. You can draw oval. You can just make two groups. It really doesn't matter, but you have to draw two groups to represent that. And then let's start writing the values. See, for the input A, we have the output B. Input A, we have the output B. Similarly, for the input B, we have the output C. So B is mapped to C. And then C is mapped to C. Okay, C is the input. It is also mapped to C like that. Now let's find out whether this is a function or not. See, A is mapped with B. A is mapped with only B, so only one output. Okay. B has only one output. B is mapped to C only. B also has one output. And here C is mapped with C only, nothing other than that. So C is mapped to C. That's also only one output for C. So this one, because each element has only one output, this is a function. So this is a function. So remember, in case of function, here is the key now. In case of function, it can be one, or I can say many elements mapped to one. See, here, two elements are mapped to one. Many elements mapped to one, that's fine. Many to one is a function. But here you can see one element is mapped with many. So one to many is not a function. So I think you can take that note. Let's write that note. Note. The first one is, here you can see one element mapped to many. More than one, I call many. So one to many is not a function. Is not a function. Sometimes they are confusing, so that's why I'm writing them. One to many is not a function. But here you can see many, B and C, more than one, many of them mapped to one. So many to one is a function. So many to one is a function. Many to one is a function. So that's how we can check whether the given relation is a function or not. So what we have done here is they have given the relation here in the form of ordered pair. See, they have given everything in the form of ordered pair. A comma B, C comma D, A comma C, ordered pairs. Here also we have the ordered pairs. What we did is we represent the ordered pair form of relation to these mapping diagrams here. And by looking at the mapping diagram, we were able to tell whether they represent function or not. But while doing this, the key thing that we have done, or the key note from the definition that we took is this one. Input value leads to exactly one output value. So that is very, very important. Input value leads to, okay, exactly one output value. So that is the key there. Input value leads to exactly one output value. In that case, it's a function. If we have more than one output value, it's not a function. Okay, that's our first example. Before we move on, if you have questions, you can send me through the chat or you can unmute and ask questions. Otherwise, we'll move to the second example. Okay, looks like there is no question. So let's move on to next example. So here is the second example. It involves diagrams, so probably it will take a little bit of time for you to copy this. So please copy the question, and when you copy this graph, just sketch it. You don't have to draw perfectly, just sketch it. So please copy the question first, then we are going to talk about it. Okay, I hope you are done copying it so we can talk about it now. Sorry. Okay. So here in this problem, we are asked to use the vertical line test to determine whether the graph represents function or not. Okay, so we are using the vertical line test. So first, we are going to talk a little bit about the vertical line test. So what happens is when the graph of the function is given, then in order to determine whether it's a function or not, we draw the vertical line. And if vertical line crosses the graph at only one point, that's a graph, that's a function. Otherwise, it is not a function. So we say for a function, a vertical line must cross the graph, let's say its graph at one point only, okay? For a function, a vertical line must cross its graph at one point only, because what we know is the same thing. See, in the beginning, what we say here is for the individual input value, it must have only one output value only. That's why the graph must cross, the vertical line must cross the graph at only one point. So for example, let's draw some vertical line and then test this. Just a second when I bring a line. Okay, So I'm going to draw the vertical line in the second graph first. You can draw wherever you want, but I'm going to try at the second one first. If I draw a vertical line to the second one, here you can see, okay, if we draw the vertical line over there, what you can see is the vertical line crosses the graph at only one point. You can see it crosses the graph at only one point right there. Okay, if it crosses the graph at only one point, then this graph represents the function. So this graph represents the function. So that is a function. B represents function. This is a function. B is a function. You can draw wherever you want, but make sure you try to cut at more than one point if possible. That's what you look for. For example, in the first one, if you look at the first graph, and if you try to draw the vertical line, you can draw wherever you want. Okay, try to draw the vertical line. Wherever you want to draw, you'll see that the vertical line will cross the graph at only one point. Okay, it will cross the graph at only one point. Wherever you want to draw the vertical line, it will cross at only one point. So if it crosses the graph at only one point, then we can say that the graph represents the function. So this graph represents the function. It is a function. So that is also the function. Because the reason is for this input value, it has only one output value. If it crosses the graph at one point, then for each input value, it will have only one output value. Now let's look at the third one here. We have a circle there. So if we try to draw the vertical line like that, what you'll see is the vertical line crosses the graph at 2 points. Look at that, right? The vertical line crosses the graph at 2 points. Here is the 1 point. Here is the other one. That means it crosses the graph at 2 different points, more than 1 point. So if if the vertical line crosses the graph at 2 different points, then the graph is not a function. So this graph does not represent a function. That means a circle is not a function. So that is not a function. Not a function. So you can see today we are really focusing on the fundamental concept of function, determining whether it's a function or not. In the first example, where we look at the mapping diagram, we created the mapping diagram, okay? And then we determine whether it's a function or not. And in this one, what we did is we used the vertical line test to determine whether it's a function or not. So vertical line test is one of the methods of determining whether the given graph represents a function or not. And in that, for a function, a vertical line will cross the graph at only 1 point. If it crosses at more than 1 point, it is not a function. So if you have any question, you can send me through chat, or you can unmute yourself and ask now. Okay, look like there is no question. So we'll move on to next example. Next example is a little different. First, copy the question and we're going to talk about it. Please copy the question. Okay, let's talk about it now. I hope you are done copying it. So here the question says sketch the graph. So first thing we want to do is we want to sketch the graph. We are not drawing a perfect graph. We just want to sketch the shape of the graph using technology. If you don't know how to do it without using technology, that's totally fine. You can use technology. You can use the online softwares like Desmos. Okay, you can try there. And once you draw the graph of each of these, we are asked to determine whether it represents a function or not using vertical line test. So once you draw the graph, after that, you have to use the vertical line test. Using the vertical line test, you have to determine whether it is a function or not. Okay. Using the vertical line test, you must determine whether it's a function or not. So for the first one, you can also try there using your using Desmos on your computer or on your phone. So if we look at the first one, what I see is we have 3x squared plus y equal to 14. This looks quite familiar to me. I can write y equal to, look here, if I move this 3x squared to the other side, it will be negative 3x squared plus 14. So if I just look at this one, I can see that this is a parabola because it's a squared function. Okay, it's a quadratic function. So the graph will be parabola. And here the leading coefficient is negative. That means the graph will be opening downward. And we have a plus 14. That means from origin, it is shifted 14 units up. So I know those things about this parabola, so I can sketch it easily. But if you don't know, that's totally fine. You can use Desmos first, and then you can look at the graph, and you can copy that graph. So let me sketch that graph for you. Okay, so first we draw the axis, vertical line for y-axis, horizontal line for x-axis, xy. So the graph of this function, y equal to negative 3x squared plus 14, is a downward opening parabola which is shifted 14 units up. So it will be a downward opening parabola like this. And this point, it's 14 units above origin. So that will be x is 0, y is 14. That will be the graph. Now, what we're asked to do is after we draw the graph of this function, we are asked to use the vertical line test. Now you can draw a vertical line to check whether it represents a function or not. You can draw the vertical line wherever you want. So let me draw it somewhere there. And by drawing a vertical line, you can see that the vertical line crosses the graph at only one point. Okay, vertical line crosses the graph at only one point. That means this equation represents a function. So this is a function. It is a function. Okay, it represents a function, or it is a function. So what we did here is we sketched the graph. Okay, we sketched the graph, and on the graph we draw the vertical line, and we saw that the vertical line crosses the graph at only one point. If the vertical line crosses the graph at only one point, it represents function. So this one, this equation here represents the function. And remember to sketch the graph. If you don't know how to sketch it without using technology, that's totally fine. You can use your graphing calculator or the online software like Desmos on your computer and then sketch the graph. We are not drawing it perfectly. We are just sketching it. Sketch the graph. Okay. Let's move on to B. So in B, we have, let me use a different color. Okay, in B, we have x squared plus y squared equal to 9. If you want to sketch the graph of this function using technology, your graphing calculator will not give you the graph of this function because your graphing calculator has the option of y equal to. We don't have y squared plus x squared. So to sketch the graph like this, you must use the online software Desmos. So you can try there and check it. But I'm going to tell you this is x squared plus y squared equal to 9 is a circle. Okay, x squared plus y squared equal to 9 is a circle centered at origin and radius 3. 3 squared is 9. So let's draw a circle to represent that. So let's see how nicely I can draw a circle. That's my beautiful circle. Also, I'm going to draw the axis there. Hold on, that is not the good axis. Okay, this one should be a little better. Vertical axis, y-axis, horizontal axis, x-axis. So we draw a circle. That is the graph of this x squared plus y squared equal to 9. X squared plus y squared equal to 9 represents a circle centered at origin and radius 3 units. So what I'm saying is the center of the circle is here at the origin, that is the center, and the radius of this circle is 3 units. Because here we have a 9, that will be the radius squared. Now, if we try to draw the vertical line, because we draw the graph now, after we draw the graph, we have to use the vertical line test to check whether this is a function or not. So let's draw a vertical line. You can draw wherever you want on it. If I draw it somewhere there, you can see that the vertical line crosses the graph at 2 different points. One is here, okay, over here. The other one is here. That is the second point. So the vertical line crosses the graph in more than 1 point. If vertical line crosses the graph in more than 1 point, then this is not a function. So this one is not a function. Let's write this down. This is not a function. Also, remember in these 3 examples, okay, example 1, 2, and 3, we learn how to check whether the given relation is a function or not. But what we have seen is, see, in the first one here, we saw that a function, the second one is a function. So function can be represented using the ordered pair. See, we can represent function using ordered pair, or we can represent function using mapping diagram. So to represent the function, we can use the ordered pairs, or we can use the mapping diagram. Over here in the second example, we saw that these 2 are functions. The first and second are functions. They are represented by graphs. So functions can be represented by graphs, okay? And in this example, see, this one is a function, and you can clearly see the function is represented by equation. So to represent function, we can use ordered pairs, we can use mapping diagram, okay? We can use graphs, or we can use equations. So there are several different ways of representing the function. But the most common way of representing the function is using the equation like this. To represent the function, we'll use equation. So from next example, we are going to see the functions involving equations. So let's go to that example now. Here is the example. First, copy this example, and we are going to talk more about it.
Excuse me, sir. May I use the
Yes.
restroom?
Yeah. Okay, I hope you are done copying it. Now let's talk about it. So here in this example, we are asked to evaluate and simplify the function y equal to f of x as indicated here. Let's begin with the first one. Say in the first A, they have given the function is f of x equal to 8x minus 10. That is the function given, f of x equal to 8x minus 10. And we are asked to find this. Look here, we are asked to find y equal to f of 3 over 4. So in place of x, we have 3 over 4. We want to find, let me write like this. We want to find f of 3 over 4. See, if I write it like this, then you can see in place of x, I have 3 over 4. So what I have to do is, in order to find the value of the function or evaluate the function, I have to plug in x equal to 3/4. So this is equal to 8 times 3/4 minus 10. 8 times 3/4 minus 10. Now you can see 8 times 3/4. See, 8 times 3/4. Let me write that here. 8 multiplied to 3/4. Just a little bit of side work there to simplify this. See, 8 is in the numerator, 4 is in the denominator. Okay, 8 is in the numerator, 4 is in the denominator. So that is like 8 divided by 4. This is like 8 divided by 4. 8 divided by 4 is a 2. Okay, this is 8 divided by 4, which is a 2. So we get 2 times 3, that will be 6. So that means if we simplify this, it will be 6. So this is equal to 6, then minus 10. So 3/4, 8 times 3/4 is a 6. Then we have minus 10. And 6 minus 10 is a -4. Okay, that is equal to -4. So the value of this function, the value of the function f of x equal to 8x minus 10 at 3/4 is -4. That is the meaning of that. So all we have to do is we have to plug in the value of x and then simplify. And while simplifying, if you need any side work to do, you can do it like this, side work. Okay, if you want, you can do any side work like this, or you can also simplify using calculator if you want. But if you simplify using calculator, don't change anything to decimal. You must leave it as fraction. That is important. Okay, that's A. Now let's look at B. In B, we have f of x equal to x squared plus 1. So we have f of x equal to x squared plus 1. Okay, f of x is x squared plus 1. And we are asked to find f of 3. So we plug in 3 for x. So we write like this, f of 3. So clearly you can see in place of x, you are writing 3. So we plug in 3 for x. So if we do that, it will be 3 squared plus 1. Okay, it will be 3 squared plus 1 because I'm plugging in 3 for x. Now 3 squared is 3 times 3, which is a 9. 9 plus 1, and that is equal to 10. So the value of this function, f of x equal to x squared plus 1 at 3 is a 10. So it's quite simple to evaluate the function. All you have to do is you have to plug in the value of x and find its value. That's B. Now let's move on to the third one, C. In C, we have a function in the form of a fraction, f of x equal to 4x minus 5 divided by x squared plus 1. So all these three functions are different. See, the first one is without a square, the second one has a square, third one has a fraction. So now in the third one, we are asked to find the value of the function at 2. We have to find f of 2. We have to find f of 2. So f of 2 means we have to plug in x equal to 2 into this equation. So if we plug in the numerator, we have 4 times 2, x is a 2, minus 5, divided by, in the denominator, x is 2, so that will be 2 squared plus 1. 2 squared plus 1. Which is equal to, now you can see here, 4 times 2 is 8. 8 minus 5, divided by, in the denominator, see this is a 2 squared, which is a 4 plus 1. 4 plus 1. So what we get is finally 8 minus 5 is a 3 over, in the denominator, we have a 4 plus 1, that is a 5. So we cannot simplify this further. So that's my answer. The value of the function f of x equal to 4x minus 5 over x squared plus 1 at x equal to 2 is a 3/5. Okay, we got the value of the function at 2 as 3/5. Now here, we are not just learning how to find the value of the function, but there are things more than that. So let's talk about it now. If you look at each of these questions, you'll see that there are different types of functions there. So the first function here, see, f of x equal to 8x minus 10. In this function, you have a linear function. The power of x is a 1. This is like y equal to mx and b. So this function here, with the power of x as 1, name of this function is a linear function. It is called linear function. Okay, function in example 1 was a linear function. Similarly, function here in B, if you look at the function in B, the highest power of x in the function is a square or 2. Okay, if the highest power is a 2, then this type of function is called the quadratic function. It's called quadratic function. And if you look at the third one, the third function involves a fraction. It is a function involving the algebraic fraction. The function involving algebraic fraction like this one, they are called the rational function. Rational function. So there are different types of functions. There are different names for the function. The first one is a linear function because the graph is going to be a straight line. If we sketch the graph of this function, it's going to be a straight line. Okay. Second one, it's a quadratic function. The highest power of x is a 2. The graph will be parabola. And the third one here, f of x equal to 4x minus 5 over x squared plus 1. This is the algebraic fraction. If the function is in the form of an algebraic fraction, then we call it rational function. So there are several names depending on the type we have or depending on how the function is written. So we learned two things in this example. One, different names of the functions like linear function, quadratic function, and rational function. And the second thing is we learn how to evaluate the function at different values. Okay. If you have a question, you can ask me now on this one. You can send through chat or you can unmute and ask the question. If you don't have a question, we have one more for today. Okay, there is a question from Vidya. What will the graph be like for rational function? So for rational function, it depends on what type of rational function is this one. Depending on that, you'll have different types of graph. We cannot say we have a specific shape of the graph for rational function. Mostly it is determined by the denominator. Here you can see in the denominator, we have x squared plus 1. So x squared plus 1 is never 0. So you'll not have the vertical asymptotes there. So really, we cannot say that we have a specific type of graph for the rational function. There are different types of graphs for different rational functions. So all you have to do is you have to type this in Desmos and then you look for its graph. There are several different graphs for rational functions. Okay, let's move on to next and the last example for today. Please copy this question quickly and we are going to work on it. Okay, let's work on this one. So they have given the graph of this function. The graph of the function y equal to f of x is given here. So that is the graph of our function y equal to f of x. Let me write that. Y equal to f of x. And what we are asked to do is, see, these are the x values. This is our x-axis. So these are the x values, the input values. And these values are the y values or output values. The values of the functions are along the y-axis. And the input values or x values are along the x-axis. So the first one is we have to find f of 0. See, let me write that. We have to find f of 0. That is, when x equal to 0, meaning of this is, when x is equal to 0, what is the value of y? So here is your 0. See, in this number line or in x-axis, here is 0, then 1, 2, 3, and so on. You have negative numbers on this side. So when x is 0, look at the pointer or the mouse that I'm pointing at. That is your 0. When x equal to 0, what is the y value? Where is the function? If you go up here, here is the function. You can see there is the function. So let me put a dot there. So for that, the y value, you can see the y value is a 1. Okay, y value is a 1. That means the value of the function at 0 is a 1. The value of the function at 0 is a 1. So f of 0 equal to 1. Next one, we are asked to find f of 2. F of 2. So that is when x equal to 2, what is the value of the function? So if you want to see 2, look at this pointer again, my mouse on the x-axis. So here is a 2. Okay, everybody look at the screen. So here is 2. When x is equal to 2, where is the y value? You can see that the graph is down here. This is the graph of the function. Graph is there. So you can see one more time, when we have this point, the x value is a 2. And at that time, the y value is a negative 3. See, here the x value is a 2. And y value, as I'm pointing there, is a negative 3. So at 2, at x equal to 2, the value of the function or y value is a negative 3. That is a negative 3. Okay, so what you have to do is, for a given x value, you have to determine where is that graph. And for that point on the graph, you have to look for the x and y value. We are looking for y value here. So let's look at this last one, f of negative 2. F of negative 2. So on the x-axis again, if you look at the x-axis, Negative 2 is here. This is negative 2. See where I'm pointing. That is negative 2. So at negative 2, if you want to see where the graph is, so for negative 2, the graph is down here where I'm pointing now. So that is the point on the graph. Okay, that is the point on the graph. So for this point on the graph, one more time, look carefully. For this point on the graph, your x value is negative 2. Okay, x value is negative 2, and y value, let me point towards the y axis. You can see y value is negative 3 again. That means for negative 2, or when x equal to negative 2, the value of the function is a negative 3. The value of the function is a negative 3. So this is how we can find the value of the function using the graph. In the previous example, we learned how to find the value of the function when the equation was given. But in this one, we learn how to find the value of the function when the graph is given. Okay. So this is the last example. I have a couple of things to talk with you before we go. So what I'm going to do is, first, I'm going to end the recording and then we'll talk a little bit and I will release you. So let me try to stop this recording first.